one's the camera. So that's going to display everything on the camera. You've got more symbols.
I don't need to do anything here though.
On here. The laptop one, we generally just click on this. What you want to do, if this goes out, real well, can you unplug the laptop HDMI and plug it back in? So in like last time, worst case scenario, if there's a problem, you just go full screen, it's going to do this. In here, that's all in, but if say this didn't come up, you go to laptop video, properties, down here it says resolution, FPS type, change that to custom, then set it back to default, and then OK, and it'll bring it back up. So that's that one, right click, properties, and then FPS, custom, then default.
Small camera and laptop.
Custom first. Change it then. Yeah, so you effectively, and then you change it back to default. Because what you're doing is you're basically changing something just to reset. Okay. Because it's the resolution's bugger and you have to click OK.
Alright.
And this. Yeah, that's cool. So, yeah.
Well, do you mind if I put my laptop there?
Alright, so I'll show you.
Wait.
Because so it's actually just done. I'll show you why. So, I'll show you, Anita, what you're actually going to see.
Cool. So I gotta come there?
Yeah, it's just
because I can't even log in. I should say that way.
This music's see how it's got it on Royal's last output?
Yes.
Right here, right here. See?
Real life.
This one.
Sweet.
Like I'm a phone.
Coming down, but it's you who have further to fall. On to love. Better
That's nice
system.
too.
Yeah. Thank you. welcome. Have a seat. We're going to start now. Cool. Welcome everyone to Kogan headquarters. We've been in this office for I think nearly 5-6 years. We've got about 300 people who come into the office. This is where our software engineering sits. So we've got Adam from our engineering team somewhere there. And I'm part of the engineering team too, heading up the talent space. So welcome again to Kogan. A few housekeeping-ish stuff. So first thing is bathrooms. I know a lot of people have asked today. So it's just on the door, if you look from here where I'm pointing, and you've got to walk down a corridor and then there's male and female bathrooms. Help yourself to some drink and pizza, get comfortable. We've got a great lineup of talks. And I'm just going to do a bit of a spiel about Kogan, just because we're the sponsors. So Kogan is Australia's biggest online retail pure player. We've got millions of customers who shop on our site every day. Our mission is to get Australian and Kiwi customers access to the best price products with the most efficient and best customer experience ever. And that's what our software engineering team work on. We work on the website, we work on the mobile app, and we work on a few other cool products that we're happy to talk to you about. We use React in our front end. Our backend's built on Python and Django. And yeah, we're always working on solving some really cool and interesting problems. Enough about Kogan. We'll now do a quick shout out to our speakers. So first off, we have Christopher. I'm gonna say hello. Cool. Next up, we've got Simon. Cool. Zach. And then finally, Basarat, Baz. Awesome. So without further ado, I'll call Chris up on stage. And yeah, over to you. Thank you.
All right, hi everyone. My name is Chris McDonald. My mates and colleagues call me Macca, and the intersection of those call me whatever they like. I am, a little bit about me, I'm no stranger to standing up in front of a group of people. I used to be a high school teacher. I taught physics and maths for a number of years before moving into software engineering. I am quite interested in snowboarding. I'll talk your ear off about snowboarding. I also do actually quite like talking about React and software engineering. The transition for me happened after my master's, and I got really interested in the big data and learning analytics as part of the education, and then got really back into the code, and then really loved the tech stack. And then the tech stack is what has brought us all the way here today. I am really loving, at the moment, working with TypeScript. I also really love Kotlin. I really love Storybook. which is what brings us to our chat, and hopefully to the next chat as well, and its integration with Figma as well. Today I'm going to talk about from dev to design, building an atomic component library with Storybook. Okay, so through this quick talk, I'm going to give an explicit rundown of the things that we're going to cover about Storybook, but also what we won't have time to cover, but just so you know that it does actually exist. I want to cover what is Storybook, why Storybook, Storybook and React, atomic design principles, and Storybook with React with atomic design principles. Cool, so jumping in, a high-level overview of what we're going to look at is Storybook's capabilities, to usage with React, usage with atomic design principles, and some examples. We'll jump into a little bit of code, and I'll give you an opportunity if you've got your computers here and you wanted to pull down the example, but you can also do that. Things that we won't have time for, we won't cover testing, accessibility, previewing, publishing, deploying, or distribution. So first of all, what is Storybook? According to the people who make it, Storybook is a front-end workshop for building UI components and pages in isolation. Storybook helps you to develop hard-to-reach states and edge cases without needing to run the whole application. Storybook can be used as a website for stakeholders to reference. Your team can check that the UI looks great without even touching the code. And of course, it's free and open source, so that's pretty good too. These three aspects is what I'm going to be focusing on today, what I'm going to center the talk around. So first of all, why Storybook? Well, because design validation is hard. Consider our one component state with then multiple, one component with our different states that we can expect for the component across different browsers, across different viewports, and across different accessibility considerations. To comprehensively test your component, now you have an exponential of states to cater for. Storybook provides a paradigm for explicitly defining these states, and they call them stories. Stories, along with the feature-packed user interface, makes catering and testing for states easy and explicit. Much easier than manually altering the DOM, that's for sure. Why Storybook? Build UI components in isolation. The main principle of Storybook is the modularity of its components. Each component, regardless of size, can be turned into its own story to be developed and tested in isolation. If we have a monolith of an app, or we have a complex authentication flow, we don't want to have to traverse this whole flow just to test the changes. Storybook supports hot reloading, so we see our changes almost instantly. In this animation, we can see one button component being split into two separate stories to explicitly demonstrate the primary and secondary states of the button. Extending on this idea, here's an animation of a different component from Storybook from their showcase reel. Take a look on the left. We've got pie chart, sparkline, range slider, time frame. Okay, so these are where I want you to look. Each of these examples have their different states that we can expect to see the component, the behavior that we expect the component to exhibit. There's two things I want to point out here that we can see on this slide. Number one, that each of these different story folders have an overview. This is a form of Storybook documentation, which I won't be covering, but it's really nice to have. And number two is down the bottom, second half of the screen. This is the add-ons UI, and it really is the powerhouse of Storybook. In here we have a list of controls, interactions, design, accessibility, actions, and this is where developers can bring the power of collaboration without code. I'll be diving into a little bit more of these ideas, but in particular focusing on controls. Third point of 4 of why Storybook, building on the variations, but also capturing and explicitly defining our edge cases. So we have modularity, control, a feature-rich UI. All of this enables us to easily test these as many as we can of this n number of states outlined earlier. Here we're seeing a story that's created to demonstrate the state where there's no selections made and the expected behavior of the component. Down there we see both the start time and end time are undefined, which just means that we're not actually putting in anything, and still we see how the component behaves with that input. Lastly, why Storybook? Because we can publish our library for review. Storybook scripts come with the package and can create a static web application capable of being served by a web server. Having a published version of the component library enables another level of collaboration, not to mention versioning. This published version can then be viewed by any stakeholders without having to check out the code. I've only just scratched the surface on what can be done with Storybook, but I'd like to jump into some more of the technical details, and in particular, React. So if anyone's used React Cosmos before, it's very, from the outset, when I first saw Storybook, that was the first comparison I made. If you're on React Cosmos or you've tried it before, I really recommend giving Storybook a go because the learning curve is very small. I'm going to jump into an example, and I just realized I haven't shared this with anyone, so I'll share it afterwards, the link, but what I'm going to do is I've already done these 5 steps here. It's an example, it's an example tutorial, and I just want to show Storybook in action before we go any further. Cool. So, on the mouse again, here we go. Okay, so as part of your learning journey with Storybook, go through the tutorials, and what we see here is just kind of like an entry-level React. We're looking at JavaScript, we're looking at no TypeScript, and what we have is a demonstration of the story layer, and then a little bit of a demonstration of the interactivity and how we can modify these components with our code. So when I jump over to the tab, okay, we have our Storybook application running, and we have 2 different components on the side, task and task list. And I will jump into the code in a moment and show what that looks like. How many stories can we see, and how many components can we see? From the outset, we have a task under the list components. We've got a task component and a task list component. And in the task component, we have a default, append, and an archive story. And in the task list component, we have a default with pin task loading and empty story. What defining these stories enable us to do is look at each of these edge cases or states explicitly. So we can see that there's a little bit of code here, which is left by the developer. Doesn't have to be, it can be completely stripped away. And we can see what the component would look like when it's actually running in our application. Default, pinned, we can see over on the right, we have a star icon there. Archived, looks slightly different. Okay, so these are our different states of our component. What about our accessibility considerations? What about our different viewports? What control does Storybook give us over those? Well, within this UI, this feature-rich UI I mentioned before, we have access to very easily small mobile, large mobile, tablet. Say we wanted to also have a look at the individual DOM items. It's not so pronounced there. Say we wanted to simulate blurred vision. We have all of this just at a few clicks without having to alter the code at all. Okay. So we don't want any of this UI, and we just want to see what it would look like in a full viewport. We can go over to our new tab, and there we have it. Okay, really, really fine-grained control, but also no code. Jumping into our second component that is provided at this version of the tutorial is we have a default task list, which is a component that's made up of a list of the tasks. Okay, so we've got a default one that looks like this. We've got some hover states here. And if we go to with pin tasks, we can see that it's slightly different. So this is being defined in our story, which we'll look at in the code in a moment. But what I wanted to show you is that we can actually give the power to the people who use this application to say, well, I want to change the state, I want to change the props without changing any code at all. So if I change this loading to true, what do we expect that's going to happen? I had a guess.
Maybe a spinner.
What's that?
A spinner checkbox.
Spinner, checkbox. We've got a state over here that's defined as loading. So if we have a look at what this looks like, so what we're going to do is we expect that these, if we change the data or the props that are driving this component, hopefully it's going to look something like that. And that's what we see. This is one really basic example. You can customize every single prop that you pass in, all of them. This is just an example of just one, and how the person looking at this and using this doesn't have to know any code to change that, to see what the different states or the behavior of the component will look like without changing any code. Jumping into the code now, very briefly. Okay, so I haven't made any alterations on this. This is straight from the tutorial. What we see is that we've got a React, repo, and at the top, we've got a .storybook file. So, directory. Now this is what drives that UI. So don't delete this because then it won't work. Okay. This comes out of the box. You don't have to do anything to alter that. That's all well and good. Down here, we have our React components that we're building. So this tutorial comes with 2 React components, a task and a task list. So what we do after as we start to build out our component, we also accompany that with what's called a story file. And in our story file, that's where we manually define or explicitly define all of the states that we want to test for. Here we've got a default state, our pin state, and our archive state. So this is what the code looks like that drives this. Just want to pause there for a second and just touch on how granular and how easy it is to make these changes. So say I wanted to say, what's that, test task? Let's go Kogan task. There it is, already ready to go. We don't have to navigate through our app. We don't have to simulate authentication. Say this was part of the auth flow. Okay, we can just, it's run completely in isolation. It's pretty handy. Although this is an example of JavaScript and JavaScript only in this tutorial, I've only used Storybook with TypeScript. The support for TypeScript is phenomenal, and I completely recommend it. So moving on to atomic design principles. Really briefly, I just want to introduce this idea that atomic design, or building our React application with components that are following our atomic design principles involves starting at our smallest thing that we can think of, like our colors or our typography, and there are atoms. We use our atoms to build everything else. Once we've defined or got our React components that are our atoms, we can then build our molecules which use our atoms. So our molecules are our React components, our reusable components that use atoms inside them, and so on all the way up to templates. Templates might be made up, you might build a template which has organisms inside it, which has molecules, but it might also just have direct molecules in them. And we use the templates combined with organisms or other templates to build our pages. Bless you. What this might look like with Storybook is we have our atoms, our molecules, our organisms, each with our component, our React component, each with its story file. So our atoms in this case might be our colors, icons, our sand grain, which I'll touch on in a second, and our text. Our molecules might involve our button, our hourglass, icon, button, link, or sand. And our organisms are what I'm calling experience 60. So this is just just something I was working on the side that I thought I'd weave into this example here. And I'm going to jump into to one last demo to demonstrate what this looks like in practice with atomic design principles and also React and Storybook all in one application. So what I have cool. So it's saying it can't find the one called default. That's because I'm not using theirs anymore. I'm using mine. Cool. So what we're seeing here is a something I've been working on. It's my first foray into WebGL. It is a relatively basic application, but I could very quickly see that as we started to get more and more complex, it's going to be very not only labor intensive for the computer, but really hard to navigate throughout and make changes if I'm not following this kind of this pattern. And what I actually decided to do was to bring some of these 3JS components, React components, into Storybook. So although we might start off with something like an icon and build out our icon button as a molecule, which uses an icon, and then we would have organisms that use that. What I did was, I actually started with a sand grain, which is in 3D, and inserted that into Storybook, and it handles it fine. And then said, well, what if we look at that, but instead of one, or to build the thing on the right, I need to use that atom, and I need to use it, and you need to use more of them together. So what does sand look like? This concept of sand, so multiple sand grains together. And this is what it would look like at the very beginning. So if I reset this, for a fraction of a second, that's what it looked like. What does it look like with gravity set to -20? That's what it looks like. What if it's set to +20? That's what it looks like. And we get that really fine-grained control without actually having to go into the code or without having to run this. The thing on the right is, this thing is chugging. Like the physics, the amount of calculations that are going on there is just crazy. But having that isolated allows me to make these really minute changes really, really easily. Got an hourglass here, the prototype we can investigate by itself, be easy. And then I can build up the experience, but without the static React components, and then put that together as a template with our organism, multiple molecules composed of atoms. So today I just wanted to show you a tool that I've been using, and maybe you use it. I really recommend you give it a go. It's called Storybook. I laid out 4 really good use cases, not good reasons why you would give it a go. It works really well with React. It works even better with Atomic Design. Even no, let's forget about that. It works even better with Atomic Design. And what I've found out very recently is it works extremely well with Three.js. Just a little Easter egg there. So, thanks everyone. Any questions? Yes?
Have you published your storybooks anywhere?
No. Not. I have published before, none of my own.
Okay. What services have you used to publish the other ones?
Also, you could use GitHub Pages.
Yeah, right.
So I intend on, well, if this is just a private personal project, I don't need to publish it because I can just view it on my machine. Storybook have guides on how they make their money through another platform called Chromium, not Chromium, Chromatic, that's the one. But they also give you guides on how to use GitHub Pages and lots of free services as well. So you just run a script, yarn storybook build, it spits out a directory, upload that to your GitHub Pages, and away you go.
Thanks.
Remember the example with the loading?
Yes?
That it needs loading. Did it get the name from the next one in the row?
You can define the name at any point
Or it
along
was
the way.
defined somewhere else?
It was defined manually
Yes.
in the story component, in the story file, but you can call it whatever you want.
No, where was it defined exactly? That's the question. It was defined using code.
Yeah.
Okay, that's what I'm asking, not
Yeah.
that.
In order that your component works in a storybook, your component needed to be presentational components. Your components needed to be presentational components.
Yes.
If our data is not passed via props, but we use custom hooks to get our data
Yes.
and fetching, how in a storybook we can handle it?
So that's exactly what I've done with what I've had to do with mine, and they have examples on how to do that. So in that case, what you'll see, just wondering how easily I could get it up. Probably not very easily. In that case, what you see is I use a third file called a page file, and in that file you define your React functional component, and in that functional component you emulate or you use the hooks that you would be using in the page itself. So it's a little bit of extra steps, but it's worth it. So what you saw with the 3D components that I was showing, in each of those I was using another page component, which was a React functional component, which simulated the canvas wrapper that was required to throw this thing onto the screen. So that's how I was able to give that to each of these components without actually putting it into each of those story files. So using a third page file, and there is instructions on how to do that as well.
Is there any resources that I can refer?
Say again?
Is there any resources or references?
Yeah, plenty. Like the documentation on Storybook's actual site is really insightful. Yeah.
Just to put my 2 cents in, there used to be, and I think there still is, quite a strong push to separate presentational components and data components. So you would nest presentation components that are driven by props inside other components, or often you can see in the pattern with any of the state libraries that have higher order components, and you can wrap those higher order components around a presentational component. So that separation of the data in one layer and then the presentation in another, maintaining that discipline makes this sort of stuff really work really well because you just put in a mock data source instead of the regular data source that you would use live on a page.
Any last questions? Yes, got two more.
Do you find you write stories differently for components that are going to be reused a lot from a component library versus scope for locked ones that might be embedded deep in the future?
I personally find I don't list the edge cases as much, if that makes sense. So in the example you saw where there was like 3 or 4, I might just write one, but make it very clear that the props can be controlled in these ways to be able to see them. So that's the way I tend to work.
I'm assuming like you might use the shape model. So the Storybook along with the shape component libraries, that's the previous work kind of. So how do you export the libraries for, say, user applications? You might need like not the whole collection of the components. I mean, like how do you pick and choose and then build your library for the user?
So in
web tag for that, or
with the last example I showed, the components were side by side with all of the app itself. So the library was within the app. So there'll be no. I'll just make sure that I haven't finished it yet, but I'll just make sure that the Storybook components aren't included in the build and that all of the library is accessible. Alternatively, you could upload to NPM, publish your package. Ooh. Okay, well, I'll probably stay around for a beer afterwards, so if anyone wants to come and ask me any other questions. Really interested to hear this Figma chat, so thanks everyone.
All right, you're not going to get slides. I don't do slides. And my 3-year-old's not sleeping very well, so I am buggered. So if I slur my words, it's not because I've been drinking. What you do get is a heist. Right at the back. I'm putting a team together. And you all have some very special skills that I'm going to need. So this is the layout. Got this front office area here, central office section through here, and the back office. Pretty standard layout. We come in through the front, crowd control. 2 of us move through to the back, 1 stays behind. Subdue the middle office. Come back through here, guard, 1 onto the safe, toss the safe, around 5 minutes. It's your cue to say, son of a bitch. So this is just a very dinky little example of a stack that I had to put together during a particular work project a couple of years ago. I thought you guys might find interesting just how all the pieces came together. And some of them, not the heist, but the diagram is. Some of the pieces are things you're going to definitely be using around the place, Figma and similar. Some you might have heard of, like SVGR or RxJS. Yeah, there's some of them I'm going to recommend strongly that you use to do this kind of stuff. Some of them it's just like the RxJS stuff is just because I thought it was fun. Motion Framer, Framer Motion, I should say. Again, it's one of those things where you might decide to use it or you might not, but we'll get the whole stack and you can pick and choose which bits suit you. This is all published on GitHub under my personal account, Simon Hildebrandt. You can find out more about me there or simonhildebrandt.com. I'm on LinkedIn. So yeah, this came out of work that I was doing a couple of years ago at a startup, and they had a site builder that they were working on, and they had an idea for like a little illustration of the thing that you're working on the screen. And I said, that sounds really cute. Yeah, definitely, we can definitely put a little picture up there. That sounds good. They said, it's quite detailed. I don't care. We want to change bits of it. Right? We want it to be animated. Calm down. Like, how are we going to do this? I don't know how we're going to do this thing that you're talking about. But okay, tell you what, show me what you've got so far. And so they pull up Figma, which is a very popular tool. You've probably all seen it and probably using it if you're doing anything like the sort of work that I do. And they showed me this cute little thing and they said, oh, wouldn't it be cool if this bit turned on and off or this bit changed? Like we had a little box around it to highlight, like you're editing the title, it marks out the title or whatever. And okay, yeah. Right, tell you what, like you're not going to change this halfway through or anything. And they're like, oh, is that a problem? All right, okay, so the master is in Figma. Okay, and you might change it and you want to instrument it and you want to make it complicated. Okay. All right, what can we do? Okay. Well, so I had a bit of a rummage around in the Figma file and I was thinking, yeah, okay, so we've got this export option down here on the bottom right. We've got some options. We can take a fair bit of control of it. We can make sure that there's always IDs on all of the visual components, and we can export as an SVG. Okay, that puts it in my domain. I know what to do with an SVG. I know that the componentry, the interface that we're building in React, got Framer Motion. I guess we could use that for animation. How do I get an SVG into something that I can like monkey with? How can I mold it? All right. I could just drop the SVG into the page and like reach in with JavaScript from the outside. SVGs are part of the document, part of the tree, but that seems awkward. And yeah, I don't know. I think one thing that has always really impressed me, and I don't know that everyone knows this, that HTML and SVGs, they're just DOM, they're just markup. So React can actually render SVGs just as easily as it can render HTML documents. And so once you're in that situation, once you're building an SVG document in your browser, you have a full vector drawing environment, which is awesome. Like you could, the HTML is really well tuned for some things, but SVG really gives you incredible power to do different kinds of things. So I was like, okay, right, if I can get this SVG and turn it into a React component, then I really start to get some power over it. Okay, cool. So that's where we get SVG. This is the toolkit that will take your SVG, turn it into a React component. Now the main thing that involves is just switching all the attributes, because of course in normal SVG markup, your attributes are all like, you know, stroke dash width, but React components don't look like that. You will know that they're like capitalized, camel cased, I should say. Snake cased. Anyway, you know what I mean.
Yeah.
Thank you. And so, right, I can take my exported Figma file, SVG, into an SVG workflow, get a React component out, get it onto the page, and then I can start really monkeying. Cool. So that's not too bad. Let's have a look. We've got, say if we have this like exported SVG file, there you go, lowercase attributes, Just, yeah, looks like a regular SVG. So we want to get it converted into a React component. Now, SVGR has a standard template. That wasn't quite going to work for me. I'll show you my template, which is basically the same with just a few small changes. But basically it looks like this. So this is you export a function that renders your component. And so I took theirs and I just added a few little bits and pieces. I added in this import that I'll explain later. And yeah, just sort of shuffle things around a little. And I got my own template. Cool. So this is what the exported file is going to look like. So if we pop down here, now this was all done in TypeScript originally. Didn't try too hard to continue that pattern of using TypeScript in my example. So you'll see like TSX files that have like, where's your types, you lazy bastard? And that's because I am a lazy bastard, you will not see types. So run it through that process and we get this out the other side. Now the one thing you might notice is that these have suddenly stopped being lowercase g's and become capital G's. Because I want React components that I can grab a hold of and do interesting things with. So I need these to be React components that I own, not JSX markup like a lowercase g that will just spit out a regular SVG. I want a first-class React component that I control. So that's not an SVG thing, and as much as I searched, I couldn't find a way to do that in vanilla SVG. So I thought I was stuffed. I thought that's the end of this particular experiment. I'm not going any further this way. And then I rummaged around and looked at SVG's documentation. They said, of course, for advanced features, you might be interested in the AEST that we built. So abstract syntax tree, if you're familiar with Babel or similar sorts of technology, it'll take code or a document or similar, parse it into a sort of a data representation of it, and then give you an opportunity to munge that, to mess with that structure. And I was like, oh, okay, I'm going to write a plugin for an AST now. I didn't think I was going to have to do that. But all right, I'll take a swing at it. And I did. So it's one of the packages you'll see in this monorepo is this Babel plugin SVG replace JSX tags. The plugins that SVG knows how to interpret, knows how to work with are Babel-style plugins. That's the name. Babel, if you've used Babel to transliterate any of your JavaScript, you probably have some sense of the fact that like it just parses it into an AST, and then you get a whole bunch of plugins that know how to turn ES6 to ES5 and various other things. So yeah, and it's really, really simple. Like you literally just write a little function and publish it. That says, oh, I'm a node visitor. I'm going to go around and based on my config, if I see a node that has a name that I recognize, I'm going to change it to the one that I know. So the SVG, my SVG config is literally just we've got some Babel plugins. One of them is this SVG replaces JSX tags, and we're just going to replace path with path, G with G, rect with rect, linear gradient with linear gradient. Just give you a sense of like all of the different sort of like any tag you can replace. So I thought this was nonsense, and I'd done it terribly, terribly wrong. But if you look in the code, you'll see me link to the actual GitHub discussions post where I post my horrible JavaScript, but I'm like, this is clearly illegal, right? This is a terribly written plugin. And the SVG guy says, no, that looks great. That's cool. Go for it. Like, oh, thanks. Cool. Okay. So it doesn't suck, and also like you're giving it the thumbs up. That's yeah. So extra thanks to him. Like this is just as a side note, open source projects thrive on this kind of like positive interaction, and yeah, it makes a big difference to not be ignored on something like that. So yeah, ask the question, and then yeah, if you're maintaining a project, answer the question. We really appreciate it. So yeah, so we can get our SVG into a React component, into a custom React component that's got customized classes. That's pretty cool. So at that point, I would say like that's the meat of this. Like SVG is cool. It's heavily customizable. You can do all sorts of cool stuff. We could stop there. But if you're curious how I got this nonsense and how it does all of this, I'll quickly run through how that all works. You would have seen in here, the main thing that's interesting here is just that I pull these custom components in from this animatable SVG thingy. That's actually published as part of the actual demo project, which is also in the mono repo. And these are just, it's like a higher order component. I just wrap a bunch of tags and create React components that know what tag they are. So there's a rect component that knows that it's supposed to be publishing an SVG rect inside. As I mentioned, I use frame of motion for this stuff. You could do this in any way you want, but this way worked quite nicely for me. So I get a frame of motion tag because it has this naming convention of like motion.div if you're going to animate a div. So this is the equivalent of like motion.say rect to get an animatable rect. We give it an idea. We got this subscription thing that I'll get into in a minute, and then yeah, we just to use these this animation context from frame of motion. We just need to drop the scope in as in this ref slot. We use initial and animate. If you're familiar with frame of motion, this is how you can like set an initial state on an animatable thing. And then I just smash the remaining params through, the stroke width or whatever that's on the path or the dimensions that's on the group or whatever. Just smash them straight through onto the actual SVG component. So yeah, that's all pretty simple. That's all the machinery. The only thing that's left is the brains. So you might see we're using an animation context, or this context here called animation context, and that comes in from here. So to drive this in the browser, we need an event listener so I can mash the space bar and push it forward and hit backspace and go back. And so that's all that's actually that's outside of this. That's like the interface component is literally just that stuff, and we drop in the context in index. Yeah, so animation context here, interface component here. Interface component is just me smashing the spacebar, and then yeah, so the brains are all in animation context. So this knows which stage of the animation we're up to. With this step count, we can advance forward or backward. It might look a little strange. We've got a -1 advance, that's going backwards. And then we just index into this step actions array, and we just broadcast that onto a bus. Now it's an event bus, RxJS. Just thought it'd be fun to try out. I've always wanted to do some RxJS, and using it as a simple event bus is pretty easy. That's the sneaky little thing in here, is this subscribe in this use effect. We subscribe to events coming out of there, and then we just, whatever we get from that, the payload of that event, we just hand off to frame of motion and say, I guess we're animating with whatever's in here. So yeah, so this is just a context provider, and we just make available these details further down the tree. And yeah, so that's how I chose to drive the animation stuff. And the only thing that's interesting beyond this is just the data that sits behind it, which is I have a bunch of defaults. I just make everything that's supposed to be invisible, opacity 0 at the start. And then I've got these steps. So to give myself, because I'm a React developer and I think a lot about like migrations and stuff, I'm always aware of like, if I have a step that goes up, I want to know how to go back down again. And so the step array is an array of objects there's a key of 1 for going up, and then there's a key of like -1 for going back down. So yeah, I just built up a bunch of steps. I'm sure you could orchestrate this in a dozen different ways. But the information that's in here is just data that just goes straight into frame of motion. It says this SVG component should be opacity 0, or it should be flicker. So flicker is a custom thing that I built, which gives quite a complicated set of instructions to frame of motion, saying, I've got multiple states for you, multiple levels of opacity. Over a duration of 0.2 of a second, I want the values that have been specified in other places to land at these offsets from 0 to 0.2 seconds. Frame of motion is really powerful, and as an aside of like all the other stuff I've talked about, you might want to check it out if you want to do it. So we use at that place, and me personally use Chakra UI quite heavily, and it comes packaged with frame of motion for its internal animations. So often you've already got it available anyway. So yeah, that's all the bits I pulled together. SVGR is awesome, super configurable. React is pretty cool. SVG is a document just like React, like React generating HTML, it can generate SVG. That's an incredibly useful thing to know, and hope you enjoy the show. As I said, this is all available on GitHub. First question.
How did the heist go?
You'll have to come along and find out. Next Saturday. No. Any other questions? Yep.
This is very cool, but what's the advantage of this over just like stepping over 5 different SVGs and showing the next one, hiding the next one?
So it's quite subtle, I would say, as I'm jumping through it, and I'll go back through it just to give you a bit more of a sense. Like, so fade out, quite finely controlled. Flicker coming in, flicker. SVGs, there's a line trick you can do with the dash, which you can grow the dashes along the line. And there's like lots of little rotations, like little fiddly bits and pieces that you can do. This is like a few minutes work of like dicking around in Figma and stuff. You can do much more sophisticated animations than this. You know, this is programmer. I'm really terrible at design and really know very little about animation. So please don't think that my amateurish animation represents anywhere near the stuff you can do with SVG and with frame of motion. There's a lot you can do, and you can make it really interesting, much more interesting than this.
And then when you like identified the paths, did you have to do that manually?
Sort of, yeah. The Figma has like the hierarchy of things, and they've all got IDs in them. And then, yeah, as you might notice from the data, the most annoying manual thing is to muck around with individual IDs and like shuffle them around and stuff. I also don't really recommend writing your frame of motion animations by hand as well. I would say about a third of my actual development time was just monkeying with this flicker thing to make it even vaguely interesting. Annoying as. But motion graphics people have tools for this kind of stuff. They know how to do this stuff right, and they probably have like libraries for React that do this sort of stuff right as well, not stringing it together like a developer would, which is what I did. But yeah, once you have a React component, you can sit in this really nice space between form and function, between presentation and data, because you can instrument the SVG with any data you want. You can pack it in other React components, you can overlay it, you can hide it. Yeah, it gives you a tremendous amount of power. Any other questions? Yeah.
What's the thing you're actually doing with React with each of those components, rect, all this sort of stuff? Like, to me, looking at that, it looks like it's an ID on something, and then some CSS classes get applied to it. What's the actual React part that's happening?
That's a really interesting question. And you know, I don't necessarily know in that much detail. I really do just like give it to frame of motion, and yeah, it pops an exception if you try and step past the last animation frame. It doesn't break, but you can, yeah, just stops you doing anything else. That's what that is. It's not bad programming. That's me telling myself, don't try and advance past the last frame. Yeah, so there are like a lot of SVG elements in here, and they get, like, you can see the opacity and stuff, like the CSS is like, frame of motion is applying styles directly to the elements in the DOM. But yeah, I don't know heaps about how frame of motion actually works. I just know that it does. So yeah, definitely give it a look. But also, yeah, I mean, if you choose to use something else, then you'll have a different experience of it as well.
I guess you need it in React for Framer to do what it wants to do.
Exactly. Yeah. That was the bit that took me the longest to like work out in my head. I'm like, I want to use Framer motion, but I'm not, I don't own those components. So how do I uplift them so that I can then plug it in? Yeah. Took a bit of brain work, but I got there. Any other questions? Thanks for your time.
It's really cool.
I was very pleased with how the finished presentation came out. Yeah. I said to my wife, like, I can't use the original from when I first built all this stuff. So what's the way to do? She's like, yeah, look at it.
Oh, okay. There's no.
And I'm like, it's a heist.
Like, there's no audio presentations. I was ready. Oh, yeah, you can see that. Okay, so that's that. Ah, okay, gotcha. And then I should be able to just make it. And then slide that. So is this one working? Test, test. Yep. Hey everyone, I'm Jensz. I'm currently teaching myself React. So I thought I'd share something CSS with you, because I assume you already know all the React stuff. So this will be about exploring container queries.
So put your hand up if you've used media queries before. I see some people without their hands up. Has everyone used a media query in CSS? Good, all right. Now, who breaks their code into components? You're all React devs, I assume. Does everybody break their components down into, or break their code down into components? Well, container queries are basically media queries at the component level. So rather than having all your styles for how things break, all your breakpoints global, you can have them sort of on the component level. Okay, so say for instance we have a section. Sorry, I thought I'd be facing the other way. No, I'll just copy paste it from my other screen. I'll just go off this one. So say for instance we have a section with multiple articles and we want to style each article based on the size available to it rather than the size of the viewport. So we could have here where we have our global section here, could have display grid and then 2 columns. So you can see here we've got 1 column and then a second column. And one's 2FR and one's 3FR. So what we've got here is we could change this to a media query. And by the way, this is new syntax. So traditionally you'd have a min width. You can also now have a sort of a more programming style query. Let's say we've just got a regular media query with a min width of 20 rem. So does everyone know what rem is? CSS unit, rem? So basically, if you change the font style or the font size in your browser, 1 rem is default to 16 pixels. So it's sort of more friendly to people who want to increase the font size without increasing the size of everything. So it's sort of like Zoom, but just for text. So it's one of the new, or not very recent, but it's been around in CSS for maybe a decade or so. So it's one of the units to remember. So say we have min width 20 rem. So you can see here, here's about 20 rem where our media query kicks in. But you'll notice it's based on the viewport width rather than the width of the component. Say we wanted to wait until the actual component itself was 20 rem, we would change this back to how we had it, where we've got a container query, and you can also add a name. So if you have many container queries, you can have different names for each, so they won't conflict with each other, and you define this up here. So you can do a container type, and then there's inline size, size, and normal. So inline size looks at the width of the parent container, and it basically says, if I've got a fixed width, what is that width, and style myself based on that. So it kind of changes the context that it's in. Normally the parent tells the child how much width it's got to play with, and then the child grows in height based on the width available to it. So if it hasn't got much width, it'll grow really tall, but if it's got lots of width, it won't need to be as tall. So normally the child the child controls the height and the parent controls the width. So that's inline size. But you can also choose size, which is a bit dangerous because then the child controls the width and the height. And so the parent can't control that. So if the actually the parent controls the width and the height, and then the child has to adapt to that within the container query. And that's dangerous because you might have lots of content and the parent wouldn't know. You're just explicitly setting the width and height. So I'd typically avoid just the size. I'd go for inline size. And then there's also normal. There's a lot of new style queries coming out. They're not yet in browsers, where you can use basically a container query where if the color is red, you can do something else, which is really complex. So today we're just talking about inline size. And then you can also set a name. So if you have many container queries, you can give them each a name. And then there's a shorthand where you can define the name and then the type in one line. So that's on our parent. So this is the article. Oops. So on the article, we're defining the container, and then the div, well, this is a bit of a terrible wording, but the article is the container, and then the div is the child of that container. I don't know why I gave the class container. There's a lot of containers in HTML. So with our container query, we've defined inline size on it. So that's sort of giving a hint to the browser, sort of performance-based. You're a container, so we might be using container query stuff in there. So it's sort of, when the spec was written, that was added sort of as a performance optimization, as well as sort of knowing what's a container and what's not. And then the div class container, that is what we're actually styling within the query. So we're changing the color to hot pink, as you can see, when we get to a certain width. Now you notice this needed to be much wider than it did before with the media query, because this pink box here has to be 20 rem or more before it becomes pink. So we could change this to 30. And now we have to grow it larger for it to kick in. So I want to show you why we might need all this. So this is something by Una Kravitz. She's a Google developer advocate, and she's put together this example where we might have a card, and based on the width of the screen, we could have the card use the full width and grow large, or on smaller screens, it shrinks and like pops down. So this is really good for like mobile first design, where you can have the mobile design and then it grows with the width of the screen. Another cool example is this one, where you can actually hide content if you don't have enough screen width. So you can see here we've got the full add to cart button and we've got a description here, but if you shrink the viewport, the add to cart button shrinks. If you keep shrinking it, the description disappears, or that first pops down. The add to cart button shrinks again, so that's a second shrinking. So first it shrinked just in this landscape view, and then it expands again, and then it shrinks back, and then the description disappears, and it can just keep on shrinking. So you can define lots of container queries in here and just sort of tell the browser what you want it to do when it hasn't got enough screen real estate. So it might not be super important to have all that description information on a small phone. You might just get the user to go into that page. How many container queries do you think are in this? Like not queries, but actual, how many containers do you think are in this card here? Hands up for 1. Hands up for 2. 3. 4. Actually 2. So this add to cart button, that's one container. And then the card as a whole is another container. So you can see here, the cart button is one container. Actually, cart icon's another one apparently. Maybe some of you are right and I was wrong. That's embarrassing. Or maybe I'm just confusing myself. There we go, the card's another container. I deleted some stuff out of this example to simplify it, so maybe it's still got it in there. But essentially, we've got this card container, and that's got all the styles to like disappear the description, and then there's the button container to disappear some of the text when that shrinks. So basically, you can like compose all these things together and build like really complex layouts that adapt to the screen size. And this is sort of moving beyond responsive design and more into intrinsic design, where you're looking at the components in your site themselves, and sort of rather than telling the site how to look at a sort of a macro level, you're looking at the individual components and seeing what size they want to be, how much screen real estate they've got within their context, and adapt them based on that. So we've also got a bunch of new units with these container queries. So is everyone familiar with viewport units? Like VW, VH, VMin, all those? So now we've got container query units, which are basically viewport units, but for the container query you're inside of. So just replace V with CQ, and you've got the width and height at the top there. And then we've also got, anyone heard of logical properties in CSS? New feature. So if you know some like Japanese, there's like vertical characters where the inline direction is actually up and down rather than left to right. And CSS has these new features where you can actually cater to that. And I haven't delved too deep into it because I can't read Japanese yet. But CQI would be equal to CQW in sort of just Latin English, because text moves left to right. So CQI would just be CQW, and CQB would be CQH. So the I stands for inline and the B for block. So I'm just using those now because it's the new standard apparently. If someone wants to view it in Japanese vertically, apparently that'll help them. And then CQ min and CQ max are super useful, because if you want to style something based on the minimum value, it'll, based on whether the width or the height is larger, it'll pick the smallest one, and max will pick the largest one. So it does the math for you already. And you might be wondering, what's the browser support on all these new features? Does everyone know of Can I Use? That's good. It's a super useful site. So if you type in container query, you'll see a lot of red, and you'll think a lot of browsers don't support this. But if you go to usage relative, you can see most people actually use Chrome and Safari and stuff, and they have, they support it with their most recent versions. And you can see there's a few people still lingering around on the older versions, but most people are using a browser that supports it. So I feel it's really good to see usage relative rather than just all the browsers, because most browsers not many people use. You can also go to date relative, and you can see container queries mostly got support late 2022, and Firefox added them 2023. So now pretty much all the main browsers have them. And you can actually go and select a country. So here we can select Australia, and it gets all the Australian data for browser usage. And it'll show you how many people in Australia have a browser that supports container queries. And you can see we have a lot more Safari people, a lot more Apple users in Australia, and a lot of people still lingering on the older versions of iOS. So once they all upgrade and get the latest iPhone, will have more support for container queries. See up here, it's about 88% of users compared to global. You can see there's a lot more Safari users in Australia. And even for the users that don't support it, if they have JavaScript, you can enable a polyfill for container queries. Any questions?
So what would be considered a reasonable amount? Like it's 88%, or would it be higher than that?
That's a very difficult question to answer. So it'll depend on like what you're building. If it's some fun personal project, it doesn't really matter. If it's a business, of course, they'll have data about their own users and what browsers they use. You know, if it's something internal to a company, you could just use the latest browser, or maybe you have old Internet Explorer needs and you can't use any of these new features. So it really depends on your use case. If you use the polyfill, you can support pretty much everyone. Any other questions?
Do you know what the support for that's like in any CSS framework, Tailwind or CSS library?
Yeah, so there's a Tailwind add-on for container queries, I believe. I'd recommend learning to do it with CSS first and then getting into the Tailwind stuff. Because again, Tailwind's a CSS file. So you could probably add the Tailwind extension and look through it and see how it works. But I think if you went straight to Tailwind, you'd skip over the understanding of it. Any others? All right, thank you.
Can everybody hear me okay? Yeah, that's fine. And hopefully my display will pick up in a bit. Yeah, perfect. Just out of interest, if we use rem for font size and rem for everything else, then when you scale your browser, then everything would scale. Would that not defeat the purpose of rem? But that's what we're doing. Like, does anybody disagree with that? I'm curious.
Yeah.
Because everybody's using rem for everything. Cool. But yeah, that is the original purpose of rem.
It's a mix of rem and viewport units.
Cool. That makes sense. Anyways, talking back to the frame of motion thing, I'm that crazy person that also modifies SVGs. So that's an SVG that's being modified with frame of motion. And that's also frame of motion animating these things in. And talking about modifying SVGs, this checkbox is also an SVG that's getting modified. And this is the code for that. Because, yeah, like you only have one life, why not play with SVGs?
You can see the motion.rect there that I was talking about?
Yeah, yeah. So the way he was doing that, he was using from motion find me rect. Yeah. What he was doing. Anyways, this is a website I'm building, Boolean Arts, education thingy. If you like it, you can come back to it. Also, frame of motion, if anybody's curious how it works by using request animation frame. You could read this documentation yourself, but fundamentally, request animation frame, but it does all those animations in a single request animation frame, so it only has one motion loop instead of setting up multiple. But you definitely do not need to know this in order to use frame of motion. Just use frame of motion, it is great. But what you do need to know is that JavaScript has memory leaks. So what is a memory leak? Anybody want to describe that? Go ahead, Sam.
We allocate memory all the time to do new and interesting things. Periodically, we lose track of the memory and we fail to free it.
Perfect. Yes. So just like a water leak causes loss of water, a memory leak causes loss of memory. Not the not amnesia, but you are holding on to memory that you should probably free up. Your RAM is getting used more and more. And who thinks JavaScript has memory leaks? You can have a memory leak in JavaScript. Cool. Hopefully by the end of this talk, more hands will raise. But here I have a function where I allocate, I've called this function allocate, a bunch of arrays of 100,000 items, and I fill them with the bang emoji, just to allocate a bunch of memory, right? And then that's the array that I return, and if I log out the result of the result.length, what do you think will print on the console right now? I'm allocating an array of this much characters, but an array of only this much size. So 2500 times of this much. Here's the thing, if I put a big number over here, it would actually even fail to allocate, so I have to come up with this weird scenario of a heavy enough object and enough number of heavy enough objects to get my machine to crash. That's not how it was supposed to crash, but it'll be 2500 of those items, hopefully, once it runs. Cool. Who thinks that there's a memory leak over here? You are correct. There is no memory leak over here. Here I'm doing the same thing. So I have just one allocation over here. I have lots more allocations over here. Who thinks that there's a memory leak over here? All I've done between these two files is just put a bunch of more variables, allocated a bunch of more variables. Is there a memory leak over here? No, of course there wouldn't be a memory leak over here. Will this run to completion? Depends on my memory, and it doesn't. I don't have enough memory. Cool. Could I cause this to run to completion? Could I still allocate this much memory again and again and log out its length and run it to completion?
You could empty it.
How would I empty it? That is the right answer. How do I empty it?
Scope it.
Scope it? Yes, that is correct. So I could scope it. I could create this thing over here.
Could you delete the variables?
Yes, that would be another solution. So one would be to scope it. So as soon as it's out of scope, then JavaScript, no, hey, there's no way that I can use result over here. So I can free up anything that result is pointing to, and that will free it up. Or alternatively, the other option was free it, deallocate it by not referencing it anymore. And that's what I'm doing in this example. So I have the same thing, except I'm using the result variable again and again, so that whatever result was contained previously is no longer accessible from any variable, and therefore JavaScript knows safely that, hey, I can get rid of that. And now, while this particular piece of code, where I was creating different variables and just logging their length, it ran out of memory, and to show that, I forgot to show that JavaScript heap out of memory. In this particular example, where I just use the result again and again, I can do this all day. I can be Captain America, and I can do this. That's not what I expected. All day, and it will be fine. I'm sure it's going to die now, but it will be fine. Interestingly, if I did the scoping trick, it really depends. It's a bit more finicky that way. It might not have worked. But if I put it in a function and the function returned, it would have been fine. Just if you stop referencing the variable, it should work fine. And that's the main objective of, that's how you get a memory leak. If you hold on to a variable that you don't intend to use anymore. So that brings us to the question that has anybody experienced memory leaks, by the way, in their, in your JavaScript code?
Seen it a lot.
Yeah, and the most common, so you can look at your memory consumption in the Process Explorer, and you see your Chrome just taking more and more memory. So clearly you have creating more memory, and I don't think anybody's doing this in their code base. So how is your memory increasing and not getting freed up? And the most common cause of that is not because of direct variable references, it's because of another magical feature of JavaScript called closures. Raise your hand if you are familiar with the concept of closures. Cool, a lot of people are. I'll simplify it. Basically, a closure is a function that closes over a variable even after that variable has essentially gone out of scope. So here I'm creating a simple closure. What I'm doing is I'm creating a new function, and this function references value. Therefore, as long as this function exists, as far as JavaScript is concerned, it cannot free up the memory allocated for value. So I am creating a closure over an allocated object and logging that out and proving that, hey, this is why I still have access, right? Because I can read its length, and I can read its length, and I can read its length. And therefore, even though the variable in this particular case is not directly referenced, because the function exists, because the function exists, the variable exists, and it cannot be deallocated, which is why you are getting a memory leak over here. Just to be a bit more boring, you can see it fail in front of your eyes. So how could I clean this memory leak if I wanted to? How could I get rid of? How could I free up? You've seen me free up memory over here. How could I free up this particular memory that's being allocated by this function? The same thing. So the memory is being, here the memory was directly being held by this variable. Right now the memory is being held because this function is there. As long as this function exists, JavaScript cannot free up the memory. So I could, for example, do, and I think I've already done that in the next example. If not, I could write that. Yeah, that's not what I've done in this example, but I can prove it to you. I can do let fn, just do that, and fn is equal to this, log in fn.length, and then I could do this all day because I am Captain America. Does everybody get that? Raise your hand if you don't get that reference. Wow, everybody watches Marvel over here? Okay, this is definitely a programming meter. But yeah, so now it's fine because the function that was holding on to the memory is no longer there. Therefore, the function can be discarded, the memory can be discarded. Or alternatively, what I did in this particular example is I didn't reference the value anymore. So if I go back to whatever this was originally, I was referencing the value within getLength, and therefore value could not be deallocated as long as function was there. And that was causing all of these functions to hold on to memory, and therefore I was getting a memory leak. No, memory exhaustion, not a memory leak. In this particular example, if I don't reference value anymore in getLength, I can do this all day. This is, you'll actually see it run faster as well, because it just allocates the memory, reads the length, and then as far as JavaScript is concerned, nothing cares about value anymore. It just needs to remember the number 2500, which is very easy to store. Cool. So we know variables hold memory. We know functions that reference variables will hold the memory of those functions as well. And that sort of brings us to the most common reason of memory leaks within JavaScript. So this is a React meetup. Use effect takes a function, and from that function, you can return something. Anybody want to answer why? What do you return from use effect? Go ahead, Simon. Thank you.
Use effect is supposed to interact with the outside world and then provide an opportunity to clean up after that. So you return something you can execute so that you can say, once you're done with this, call this extra function to clean up after.
Perfect. A person over there also raised their hand. Sorry, I went with Simon. I was scared that no one would raise their hand. As soon as he raised it, I was like, go ahead, Simon, save me. Don't let this question be unanswered. But thank you for nodding to Simon answer. That is correct. So your use effect takes a function, and the objective is, because you are doing stuff in a function, make sure whatever you do, you clean up when the component goes away. And most commonly what you do is add event listeners or whatever, interact with the DOM element. Just make sure you stop referencing that DOM element, otherwise that DOM element is going to stay in memory, and therefore you'll eventually get a memory exhaustion because of this memory leak. So here's an example. I am adding event listeners, get onMove handler. Get onMove handler is a function similar to what we saw before, allocates a lot of memory, and the function that is returned will not let go of that variable called memory, And therefore, as long as this function exists, this object is going to exist. And as long as add event listener is referencing within the listeners array whatever function I am returning, JavaScript will not be able to free the memory. And therefore, after 3 additions, similar count as before, 2500 items, it's going to run out of memory. So how would I fix this? So the use case that I'm trying to imagine over here is that you have a UI where you click on paint, and when you click on the paint button, like you're painting on the screen, as you subscribe to the move handler. So you add the move handler to the add event listeners for the UI. If the user clicks the button again and again, you're going to add the listener again and again, and therefore you're causing memory leaks. How would I clean it up?
Delete all the other event listeners.
Yeah, excellent. So remove the event listener before you add it. Lots of ways to do it. Here's a lazy way of doing it. If I have a listener already, remove it before I add it. And now I can be kept in America. Honestly, I did not prepare to say this many times that I can do this all day, but here we are. What you gonna do? Yeah, cool. So remove your event listeners, stop referencing variables, stop referencing functions you no longer need, and your application will perform better. And also, I am Basarat. Booleanart.com is my platform. You can find me in pretty much YouTube, LinkedIn, x.com. Sounds a bit weird, but that's what Twitter is called. Yeah, Booleanart.com is my platform. Cool. Any questions? You can clap if you want to, but any questions? No questions. Excellent. Go ahead, sorry.
How much memory is each site allowed to actually use out of that allocation?
How much memory is each site?
Can it use all the memory on the machine, or like?
Oh yeah. So it depends upon. So in Node, like the default memory allocation is 8 gigs, and I don't know what Chrome wants to allocate. I'm pretty sure that you could put RAM pressure to the extent you could do as much as you want. Chrome probably has a default value, but you will not hit that. So Chrome max memory, and of course other browsers will have their own. I did not expect that to be that small. Okay, less than Node is the answer, 1.4 gigs. But yeah, Ben, that's. Go ahead.
I saw someone just recently complaining about some side effect that they triggered with useEffect or some API call.
I was wrong about Node as well.
Sorry?
I was wrong about Node as well. It's 1.4 as well, so it's same as V8 basically.
And so they were seeing a side effect come in after their component had been cleaned up.
Yes.
Which is not uncommon.
Mm-hmm.
And is there any particular places, like you talked a bit about useEffect, is there any particular places that React makes it particularly difficult to do these sorts of cleanups? Or are there other libraries that are also, villains in this case?
So I had a plan of bringing in my wireless microphone, and just standing outside and asking people, what is the feature that you hate most about React? And I was expecting the most common answer would be like the dependency arrays and the callbacks. And that's the thing, right? So callbacks are not a great abstraction simply because I don't think it's necessarily React's problem. It's more of a JavaScript problem. The fact is, once you've fired off a function, that function, it's not cancelable. And so if you've, on useEffect, you've kicked something off, even if the function gets unmounted, for example, like fetch, you can cancel, it's a possibility now. But if it's all running as an imperative JavaScript, that imperative synchronous JavaScript is going to run to completion, whether you like it or not. So yes, it's a common problem of the fact that functions exist and the fact that functions hold on to memory. And they can continue executing even after the component is unmounted. What you gonna do? I can do this all day. What you gonna do? That's my 2 favorite things, apparently.
Don't get Captain America.
All right, any other? Yeah, go ahead.
How do you actually catch these in the real world when you're
Yeah.
programming with others and stuff?
Yeah, so the answer is not good. So if I go to this as an example, within perform memory, there is take a snapshot, and this is what you can look at. And then you could take another snapshot, you could record it, and then you could compare, hey, this is what was consuming memory before, and now this is what is consuming memory before, and then just look at it and cry, and look at it and cry. But that's honestly the answer. It's not too bad, because like as an example, if I have there's nothing, like if I have too many promises, that might be a sign that something, but like if I'm using classes within my code base, they would show up over here. And normally memory leaks aren't necessarily, the most common memory leaks I've seen are in networking. They're not necessarily in DOM references. It's just, okay, so when you saw the add event listener, right? And everybody loves to have a network connection. I work for a trading company. And drop the network connection, and as soon as the connection comes back, be like, hey, subscribe everything, without clearing the old ones. And that's, so you get to see the class that's handling the message payloads show up within these snapshots. But yeah, so memory to take snapshots, compare snapshots. Yeah.
Adding event listeners, how big a deal is that usually? You know, you add click listeners everywhere, all this sort of stuff. How much of a footprint is that usually in a real application?
Excellent question. Not a big one. So if I go AST.tsx and do function whatever and return div and on click is equal to this thing. This is essentially doing an add event listener for me, but it is also going to remove this event listener for me. React is sort of taking on that responsibility, just like sanitizing HTML is a difficult problem, but React does that for you. By that, I mean, if I, for example, render a variable over here, it's not going to render a script tag for me. It's going to escape the script tag thingies and render the less than greater than. Similarly, over here, it's going to make sure that this callback that I'm passing to onClick, which I've done a horrible job of, is cleared whenever this particular DOM element is gone. Any other questions? Phew, thank you so much.
Awesome, that's a wrap, everyone, for tonight. A big thank you to all our speakers, Baz, Simon, Zach, and Chris. Thanks for your time volunteering. Cool, and we hope to see you all for the next meetup. Watch this space, likely to be either Jan or Feb next year. Ooh.
Thank you.
Thank you.
Yeah.
Thank you very much for inviting.
Thank you.